or it has to have energy taken out if the movement is to slow it down, for example. It has to be drained, energy has to be drained out of it. And to speed it up, or to change its direction, energy has to be put in. This is true of things that are holding still, just as it's true of things that are in motion. So here again we have non-essentials. The Aristotelian system is dealing in non-essentials. It says some things are moving, some things aren't. We have to explain the things that are moving. Where actually what we have to do is explain motion as such, whether it's motion from a dead stop to moving or from moving to a dead stop. You have to talk about even things that are at rest and what the nature of those are. Because things being at rest are actually, there's actually nothing different from a thing being at rest to a thing being in motion if you talk about relativity in the Galilean terms from Galileo. This was an eternal confusion to the Greeks. So let's go on to the next bit of this. The essential feature of this view of the Greeks, of Aristotle, was the assertion or the assumption that a body would keep in movement only so long as a mover was actually in contact with it, imparting motion to it all the time. So it had to have energy input. This confused them. They said that there's no way that it could keep moving after it leaves your hand, unless they had to figure out a way. They had to explain their way out of this. Things naturally want to come to a rest, they said. That's not necessarily true. We'll talk about that maybe in a minute. They said things naturally want to come to a rest, therefore when you let go of it and you're not acting violently on it, nature will make it come to a rest. Now ultimately that's true through fiction and stuff, but if you throw something out into outer space and it's orbiting the sun, well, look at the planets. They're orbiting the sun and they're not necessarily coming to a rest or slowing down. So it's just not true that everything naturally wants to come to a rest. But if you believe that, then you have to explain things that remain in motion when nothing's acting on them. How do they explain this? They said that the air was pushed out of the way by the rock, and the vacuum behind it pushed the rock out of the way of the vacuum, so that air could rush into the vacuum and fill the space, and this is what propelled the rock forward after it leaves your hand. They had similar ridiculous fantasies about bows and arrows and stuff like that. Here's an interesting thought. I'll just mention first a type of spaceship engine. We're just coming out of this discussion and we're just leaping out into NASA and outer space. There's a type of engine that is called an ion thrust engine or something like that, and let's see, it's for moving things like a satellite or something, clear out, or probe or whatever, clear out to like Saturn or something, and it's basically the weight of a small paperback book or something. That's all the thrust the engine produces, but it produces it constantly, and it produces it month after month, year after year. So in the first 2 or 3 years of the journey, it's not going very fast at first. By the end of the 3rd or 4th year, it's going quite fast, and you get out there fairly quickly, quicker than you would think with an engine that's not really putting much thrust on, just constant slow thrust over time. The Greeks were confused about this. They said that a rock wouldn't slow down and fall if your hand could remain in contact with it. It could keep on going if you could keep exerting force on it. That's not true though. If you keep exerting force on it, it doesn't keep going, it speeds up. It keeps going, but it goes faster. So they were absolutely confused about this. How? What's the root? What's the problem? Where did they get off on the wrong foot? They got off on the wrong foot by bifurcating the issue to begin with. They didn't need to cut it into things at motion and things at rest. It's physical objects and energy input is the subject. Whether it's at motion or rest, it doesn't make any difference. So their confusion is an epistemological one, right from the beginning. They are uniting things by non-essential and dividing things up by non-essential. They're saying there's this fact here and that fact there, and these are important, when in fact they're not. Now it's not like they were drunk and, if they would have been thinking more carefully, they could have made the correct move. They didn't have the information. These things had to be figured out over time, and so this was a first try, if not the final try. Now this book, The Origins of Modern Science, it sounds like a great title. Now we're just about finished with this book. I just want to give a quote now, slightly off the subject, just to show why this book is worrisome, why the author is worrisome. Quote, "It is astonishing to what a degree not only this theory, but its rivals, this Aristotelian theory, but its rivals, even the ones which superseded it in the course of the scientific revolution, were based on the ordinary observation of the data available to common sense." He says this point another time somewhere on, and he keeps saying it's astonishing that theories always come down to absolutely ordinary daily observations of absolutely mundane things. And I don't know what his astonishment is about. And maybe he's playing tongue-in-cheek. I haven't read the whole book. Maybe he's trying to ham it up a bit and come out later and say, well, it couldn't be any other way. But I don't see that. I think that he's confused. I think that he's astonished. But the fact is, any theory about reality has to come from observations of reality. And this guy apparently is a bit confused about that. And he's an academic, so you wouldn't expect him to have his head on very straight. Not in these days and times, this day and age. Alright, now we're going to go to Greek Science in Antiquity by Marshall Claggett. I went through this a long time ago and decided, I've read almost the whole thing again, looking for information about the subject here, force, mass, and energy. And it's good to reread the parts I reread. And the couple of chapters I didn't read, I finally made it through, like the Greek astronomy chapter, which had virtually nothing in it. Virtually nothing for us. But we're going to go to the Greek physics chapter, chapter 6, on page 84. Now, we're going to be talking about the concept of matter here, but I transcribe it as mass, basically. The idea of mass as such, for the ancient Greeks, for Aristotle, was composed of a substratum of prime matter, quote, "the independent existence of which is only potential, but the actual existence of which is always in conjunction with form." So there's this basic stuff, and you never see the basic stuff without it being in a certain way, like in the form of a chair or a human or whatever. Aristotle wants to say, then in his theory, you can never divorce the two. They are necessarily intermingled and locked together, where Aristotle is pointing probably with this is to Plato, saying Plato's divorcing form from matter, saying that form is in heaven and matter is on earth, and the form is projected on the matter yet imperfectly. And Aristotle says, no, you never see matter without form being involved. This is their idea of the basic stuff that the universe is made of. Compare that to our modern idea of the basic stuff the universe is made of. We don't say that that there's basic stuff, but it always has to be in the form of a stove or whatever. What we say is there are atoms that have weight, and weight has certain properties. And it's across the board, all types of atoms with weight have these properties. And Aristotle, the Greeks, were confused about this, tying epistemology into the conversation about what the basic stuff of the universe is. They couldn't step back away from metaphysics and simply look at it as a physical, scientific question, the way that we've been able to with the help of generations and centuries in between. So that's their basic idea of mass or matter, the basic stuff that everything is made of, it's tied up with epistemology and metaphysics, and they're not able to look at it as simply a fact of reality to be explained scientifically. It's always got to be included with some metaphysical bizarre system. Well, we go on to the next page, and they've got some stuff about energy. Quote, "If an element is removed from its natural place, it tends to return to that place by a straight line movement."